So when we say a complex number x plus iota y, okay, so on the argand plane it just represents a point x comma y. That is the easiest way to understand complex number on argand plane. Now what makes this argand plane different? X-axis is replaced by real axis and y-axis is replaced by imaginary axis. That's the difference, and we call this thing as argand plane. Now on this argand diagram, the angle this complex number is making with respect to real axis is called as argument, or it is same as the bearing. In bearing we used to measure angle with respect to vertical. In vectors we used to measure angle with respect to horizontal. So this resembles more with vector, direction of a vector. So the only difference in complex number and vectors is, in vectors we have to go only in one direction, that is anti-clockwise direction. In complex number, for this argument, it's like a factual thing what we must know, that this theta can go in anti-clockwise direction for 0 to pi, and then to cover the remaining 180 degrees we will go in clockwise direction like this, so from minus pi to 0. So these two things if I combine, then I can say that this argument theta lies in a range of minus pi to pi, or in terms of degrees it will be minus 180 to 180. If you have any complex number, let's say 3 minus 4 iota, okay, so 3 minus 4 iota means 3 comma minus 4 as a point. 3 comma minus 4 lies over here. Okay, so what you will do in your calculator, you will simply do tan inverse of minus 4 over 3. You will get some negative theta value, and that will be acceptable. Okay, so this is how we look for the argument for a complex number.